So, to begin linear algebra, we will answer the question, what is a linear equation? And the simplest linear equation that's non-trivial looks like ax is equal to b, where b is a constant, x is an unknown, which is another way to say variable, and a is a constant. So if a and b are non-zero, so a is non-zero, b is non-zero, then a solution to this is x is equal to b divided by a. It's really simple. And that's why we like linear equations. But if a is 0, we have two cases. Because b could be 0, then any value of x is a solution. Right? 0 times x is equal to 0. That's always true no matter what x is. The tricky bit is when a is 0, but b is non-zero, then there is no solution. There's no possible x such that x times 0 is a non-zero. It's the facts of life. Now, this is the simplest linear equation that we could think of. The next simplest would be if we had, say, two variables. You've seen this in high school with something like y is equal to mx plus b, where y and x are unknown, but m and b are constants. We would rewrite this simply as y minus mx is equal to b, so that all the unknowns are on one side and it's equal to a constant on the other side. This will simplify things considerably in the next couple lectures. And if you remember from high school, there are infinitely many solutions. If you look at the yx plane, ends up looking something like this, where it goes through b and has a slope of m. Any point on that line is the solution to this equation. That's why it's called linear algebra, because we are looking at what would geometrically be lines. So the third example of a linear equation in three unknowns is something that would look like ax plus by plus cz is equal to d, where the x, y, and z are unknown. The a, b, c, and d are given real numbers. And just as when we had two unknowns, it was a line, in three unknowns, it's going to be a plane in real space. And the simplest way to look at that is if c were 0, then you would have, the simplest way to see that perhaps would be to say ax plus by is equal to d minus cz, and keep plugging in different values for z. Then you end up with a family of lines that end up forming a plane. So if you had 3 dimensions, it would end up forming a plane like that. Okay, well, if these are linear equations, what is a nonlinear equation? So a non-example, just so that we can differentiate. It would be if we had something like 1 is equal to cosine of x plus 33y cubed plus 4z. So cosine of x is not a linear function. Y cubed is not linear. At most, this is linear in z, or z. And that is basically a simple nonlinear example. It might look more exciting than the linear examples, but, well, there's an entire field of linear algebra, and that's what we're going to be studying. So we'll get into systems next time.